All right, and we're back. I'm just going to start off with intro to Kinter. So this is just another framework that we're going to be using. And again, there's two different, the reason why I'm talking about Kinter here and Pygame all at the same time is for a couple of reasons. One, Pygame, there's a lot to it, right? And I'm seeing a bit of an ad here, so I'm just going to pause for a second as I continue talking. And check some of your chat, which I see there isn't any chat right now. And I see a couple users still on with me. That's cool. I know this is not exactly convenient for all users, and that's why we're doing the video as well. And we're back. Okay. So again, both Pygame and Kinter are two different frameworks that we can use. Kinter is kind of built into Python. We can use this more simpler framework to create quick GUIs or interfaces, if you will, that work with standard buttons. It's going to look like standard windows that we're going to be able to create with Kinter. Whereas Pygame, everything that you create is customized. So we're kind of hit both of these two methodologies at once. And again, we don't have a lot of time in this course, so I'm kind of trying to cram some of this material in here so that way we can do both. And again, you can do assignment number 2 with both Pygame and Kinter. In this particular case, we're going to show you the Kinter stuff. And it's going to be a slightly different framework, if you notice, even this a different approach than the Pygame. But quickly, what I do want to mention is, if you go on the web here, what I want you to see is that Kinter actually is well documented here on the Python library. In this particular case, we're looking at Python 2.7.5, which is the most recent edition of Python for 2.x, the 2.x series of Python. So if you notice, all of your modules here for Kinter are documented very, very well online. So how to import, how to perform your import, and so on, and also how to do two different things in Kinter, how to set up the window, and so on. Everything is, when it comes to Kinter, the basics of Kinter is here as well, because I noticed that some of you are having questions, or if you're sending questions about documentation. One thing I wanted to mention was I've also changed your lesson archive a little bit. So here's your lesson PowerPoint archive. This is all the PowerPoints we have for this particular series that we're doing for our COMP2069 course, this intro to graphics. I got the code archive that's for all of our lessons, and then on the bottom I've added this new resource called textbook resources, and I've put in the online resources that I keep talking about in class, which is Invent Your Own Computer Games with Python. That's a full book if you actually were to open this up, and Making Games with Python and Pygame. So from a support perspective, these are a couple of good books, a couple of good resources you can look at from the same author that talk about how to use Pygame and Python. Okay, and they're a different approach than what I'm kind of using, but it covers the same material. So I think this is another great resource for you to look at. Okay, and I've also included something else down here, a Kinter 8.4 reference, which is a GUI for Python. I've kind of categorized it as a 2010 version. I don't think there's another version out there right now, but this is the latest update that they've got for this Kinter reference, an 8.4 version. Okay, and again, if you wanted to find that online, and again, if I was going to search using my Google Foo like we talked about before, there you go. And if I say Kinter reference, right, PDF, and you can actually find there is an 8.5 version that came out in February 27, 2013. So you can actually look at this. It's from New Mexico Tech, and you can download it for free. If you bear with me, it's going to open up in a second, right? But the great thing about this is the latest versions of Kinter, the things that are compatible with Python that we have, are downloadable. And I put on 8.4, 8.5, and 8.4 are going to be very similar. But the idea behind them is, and as soon as this thing comes up, it'll show you what I mean. It'll actually be a little reference that you can use when it comes to understanding how to put together Kinter. So even though your two textbooks that I've kind of put up online for you may not cover Kinter, this reference will cover almost like a little cheat sheet of how Kinter functions. And wow, this is really slow. And that's why, for those of you who care, I've kind of put together this reference right here. If I actually click on this, right, it's going to bring up the Kinter reference. So this is the 8.4 reference, which happens, if you know, if it's dated 2010, March 27th. And it actually has what Kinter is, you know, and so on. It's hyperlinked, so you can actually go quickly through it and understand how to use Kinter and so on, how to make a button widget and a canvas widget and all that kind of stuff. And it talks about the difference between buttons and widgets, buttons and canvases and grids and everything else. We're going to talk about Kinter. Okay, so this is a little reference that I would encourage you to use, again, when it comes to learning Kinter. Okay, so I've got given you the two things for Pygame. Here's the two Pygame references, and this is the Kinter that's online. But I encourage you to actually go online. Let me see if it's finally been. This is actually downloaded. It looks like it has. And if you notice, this is the same guy, John W. Shipman, and it's 2013, February 27th. Okay, so again, this is fairly recent, and he does the exact same thing we talked about before, which he talks about the grid method, and he just updated this document. He's keeping it as current as possible because Kinter, believe it or not, is a very common framework that scientists around the world use and different programmers without having the need to download any kind of extension modules. Okay, so take a look at this when you have a chance. And again, let's go dig right into it. So again, a couple of options I put up here in textbook resources. What I may do later on is update this resource to 8.5 just to keep current. But for now, you've got the 8.4, which is very good as well. Okay. So this is from, I've kind of taken this information from thinking into Kinter. What is Kinter, right? So really, this talks about here, in this particular slide, it talks about really what a UI is, right? And really what we want to talk about in this particular case is, and we're talking about a structured UI, whereas when we look at Pygame, it's really more of an unstructured UI, right? Or a customized UI, maybe a better way to say it, right? Pygame, you can create your interface the way you like it. It's going to suit your users. It's really good for making games. But Kinter is really a quick and dirty way of creating like standard windows and buttons and so on. And that's what I use to create my assignment number 2 solution set. Okay. So again, there's two functions of the UI. It's really, one part is how it looks, and the other part is what it does, right? And basically, what it says here is you must associate the looking with the doing. In other words, we got to listen for input from the user with event listeners or bindings. Right? And it also talks about some other GUI jargon. And I think this is a good overall, another different view of GUIs. And here they talk about callback handlers or event handlers, or even event listeners. You've heard that in the past. Kinter use something called binding, right? Which is the way that it binds the control with a type of event. And we'll look at that. It's a different method, different way of thinking than Pygame, so to speak. And we'll talk about that. It does also talk about an event loop, which is very similar to Pygame. So again, you could use the idea and alter frameworks here as well. Okay. So here's an event loop, and we're going to look at eventloop.py to just kind of talk about Kinter a little bit. So we go back to Optana and look at eventloop.py and just close up MoveBox. Right? So here's eventloop.py. And if you notice, I'm still using the main function, right? And really, this is a text-based way of looking at how events would work, right? So I'm listening for different inputs. In this particular case, I'm listening with the console, right? So I'm saying, well, is it an A or B or C? I'm actually taking raw input and I'm converting it to upper, and depending on what the user inputs, this is pretty easy to see whether you're an animal, a vegetable, or a mineral. And you can use X to handle the 2 X's of the program. This is actually a pretty cool little menu that you could have set up for assignment number 1, or this kind of system, right? Where you can pull up a menu. So that's kind of another little thing. But that's what eventloop.py does, right? But the same idea with this eventloop.py is the same things that we do with our game loop, and the same thing that Kinter does with its event loops. Let's go back. All right. So again, using the example of the idea framework, the first statement imports to Kinter. So again, a standard way, like it says right here, is from to Kinter input star, which means that, you know, we'll not have to qualify anything that we get from to Kinter with a to Kinter prefix when we use this star. When we from to Kinter input star, we could also say import to Kinter, which is what we do with Pygame. We could also say from Pygame import star, right? We could actually do that as well when we create our code as well, right? This particular case, we're showing you how to do it with the Kinter. So think about this. This star is almost like a wildcard that allows us to take away the to Kinter prefix. Okay. Second statement creates this top level window, which is exactly what we do with Pygame. So instead of once we say tokinter.tk, right? That's the normal statement. That's the instance of the class. But now we don't need the tokinter.tk. All we have to do is tk. Once we say tk, that's this tk method or class is part of the tokinter library. So that's creating our top level window, right? And we're going to say windows equal to tk, or in this particular case, they like to call it root, right? Window, root, screen, it's all the same, right? The third statement, it starts off the main loop, right? So we actually use the root and we create the window. Okay, so let's take a look at this simple tk.py program for a real clear illustration of how that works. And I did this kind of thing with some of you last week, kind of giving you a preview of to Kinter, because I know some of you wanted to start off on your assignment number 2. Okay, so here it is. So from to Kinter import star, this is our the to Kinter library. It's actually using our wildcard, and we're saying here's our main. That's an example, right? And inside there we're saying root, which is actually a screen or window. So from a Pygame perspective, this would probably be the I in the idea framework. So let me just use that in there. So if I was to enter that in, so this is the I, right? So in idea, so initialize, if I can actually type, and import, or import and initialize. This is part of that framework. Same thing as we do right here. So here's initialize and import, right? Here we actually define the window, right? So this is the display portion of the idea framework. So we actually would put in here the D portion, which is our configure the display. That's what this does, right? Which is exactly like we have in our other in our Pygame framework. We talked about the idea framework, and here we actually, what we want to try and talk about is the event or the entities that we want to define. But here there are no entities, so we don't have an E necessarily, and we do have an A, right? So this is the A portion. We don't have an E, but the A portion of our framework is the alter framework. And in the alter framework, we have a loop, which is what we're doing right here. This is the L part of the loop. All we're doing is kicking off this loop, and that's all we're doing. There's nothing else that Kinter is doing here. So actually, this is a portion of our framework, right? So again, let me just get rid of this. So we don't need any of this stuff. We're going to use Kinter the way it is right here. And this, if we press play or run the program, right, it displays a little window. Right? Now, there's a difference between Kinter and Python or Pygame. In this particular case, the way we've displayed everything, we haven't defined the standard size of a window. This is the default size of window that it creates. Okay, we're going to pause for a second for break, because it's looking like they're going to they're doing another ad. And I'm going to check the chat, see if you guys are chatting or need anything, and I don't see anybody ask any other questions. So, but otherwise, for those of you who are online, and again, I encourage you to read ahead, look at the framework. We're going to talk about different methodologies, and here's a second ad right now that's following up. Different methodologies for writing our assignment number 2. Okay. Okay, we're almost done this ad. We're going to get back to the main. Okay, and we're back. So again, we haven't really defined the size of our window much. This is the same size that we've been using from before, right? But it's almost like our default size, right? So if I click on the X here, Kinter has a built-in detection for closing off our window. Pygame does not. So if I was to create a Pygame loop without checking for to close our window, it wouldn't close. We'd have to actually exit Pygame with brute force methodology to actually close down the window. Okay, so if we actually hover over here again, what are we doing? It says class TK, so we're actually calling the TK class, which is part of the Kinter framework, right? It's a top level window that we're creating, right? And it says I'm doing a couple things, right? I'm saying inside the window itself, it's showing me, right, a bunch of different things, right? The things that I can add into the TK, this initial definition, right? My constructor includes the screen name, which is a default set to none, the base name, which is none, and my class name, which is TK, right? Again, I can add some other options here. I can create, I can add children, I can define this window, this root window as part of another class, another surface, and so on. I can do all kinds of stuff. And if you look at the Kinter documentation, it has a bunch of things that options that we are allowed to do here when we define our window. We're going to get into more of this as we move forward. Okay, so we've defined our main window as TK. This is all you need to define your window, and then we start our main loop. And if you notice, we'll hover over main loop, right? It talks about if I expand this window, right? The main loop itself, right, is I'm using the main loop method on the surface that I've created, which is called root in this particular case. Okay, or this is the top level window, and I'm just running the main loop on the top level window. That's all I'm doing with Kinter. Okay, let's go back. That's kind of our first Kinter program, right? Okay, so we want to specify how the GUI looks, as that's the first thing that they talk about here in this particular document, right? Okay, and what we're going to do here is we're going to create a GUI object, which is a surface object, if you will, just like we did with Pygame, right? We're going to talk about packing the object, and we're going to talk about containers versus widgets. Okay, let's talk about that a little bit. So there's a bunch of containers that you can have with Kinter. One of them is a canvas, which is really cool. You can use Canvas for drawing applications, like for things like if you want to make a drawing program for assignment number 3, which is something we haven't talked about today or yet, and we will talk about next week more. You can actually use Kinter to handle a lot of the stuff that happens in assignment number 3. Okay, so you don't have to use Pygame. We're going to show you how to do it in Pygame, but again, you can use Kinter to make it happen. And again, the most frequently used container in TK and Kinter is frame, right? But you don't necessarily have to use the frame container at all. We're going to see that as well, right? So an expression like frame, my parent, in this particular case, my parent is going to be root. It's going to be the top level window, actually creates a frame, another container that's inside of the parent window. And that's exactly what a surface is in Pygame. Pygame, we talked about Pygame surface, a surface object, and really it's another container that's inside of the Pygame top level window, or in this particular case, the Kinter top level window is called the root, right? We've named it root, and our frame is another container, and we can put in root as my parent here is showing, right? So let's take a look at frame and pack, and we'll look at what we can do with frame and pack, right? Packing is, of course, we're going to talk about packing a little bit more, and that's the way you display stuff into Kinter. Let's go back to tandem. So here's frame and pack. Frame and pack. All right, so a couple of things added. So here's our main function again. Again, we're accessing it right here. We're creating our root or top level window. Here's TK, we're actually activating it. And then we're creating this container. My container 1, and this could be, we could call this background, if you will, is equal to frame, and we're using root as the parent. So we're actually linking our frame, this container, to the parent top level window. That's what we're doing. Okay. So, and then what we're actually doing here is we're using the pack method, and if I hover over here, right, here we go, I'm hovering over the pack method. The pack method actually, what it does is it displays the frame, or this surface object, this container within the top level window, the Kinter top level window, and then we're going to actually kick off the main loop. Now, for all intents, it's going to be the exact same thing, except once we define a frame, and we haven't defined the geometry of the frame at all, and if you notice, we can define a lot of stuff in the frame widget. Like, for example, if you scroll down here, you can actually use all kinds of options here. So valid resource names are background, BD, background, border width, class, color map, all kinds of stuff we can actually add in the frame. Once we've defined the geometry of the frame, it'll expand to fill the window. In this particular case, we haven't defined any geometry. The frame is just saying where our parent container is root, which is our top level window. It's going to be a flat window with just a title bar, and that's it. So let's take a look at that. So if I run it, and there it is, way up here in the corner of the screen. So I'm going to move it for a second. Oops. And again, it's hard to move because I can't kind of click on anything. There's our title bar, and if you notice, it's got TK as our title because that's the default title for any Kinter window, and that's totally resizable. And if you remember, Pygame wasn't resizable. It didn't come with a resizable window at all. You have to kind of define that later. We haven't even talked about that yet. Okay, let's close this one off and go back to the window here. All right. So we talked about frame and pack, and again we talked about how this statement here, what it does is it links this new container that we've created, my container one. It links it to the parent window, which is actually root, which is the top level window. Okay, and here when we do a packing, really what it does is says, let's set up a visual relationship between the GUI component, whatever it is, whether it's a button control we're going to define, or a frame, or whatever we're going to define, with the main window itself. So we're going to actually pack this container, in this particular case, my container one, because I'm linked in, or my parent container is the top level window. It's going to pack or display the surface to my top level window, and I haven't defined anything on the surface, so you don't see anything. It just it's there. We know the frame is there, but it's there in the background. Okay. And again, what it says here, if you don't pack a component, you'll never see it, because pack is like blitting in Pygame. Okay, it actually displays the object or the control onto the screen, or on the surface that it's linked to. I think that's a better way of saying it. And again, it talks about 3 different geometry managers: pack, grid, and place. And I'll tell you right now, pack and to a lesser extent grid are most widely used because they're easier to use, but I think place is the way to do your assignment number 2. And we're going to talk about that a little bit more, because place gives you a lot more control. Okay? So here's an example of another button. We're going to create our first widget now called button 1. And remember, in Pygame, you have to kind of create your own buttons from scratch. There is no container. We have to create our own button. There's a lot of code involved to create that place to click in Pygame. But in Kinter, it's quick and dirty, like I said. So here, in this particular statement here, we're saying I'm going to create I'm going to instantiate an object, a button object, right? That's going to be linked back to my container 1. Remember, my container 1 is the frame that we've defined, right? Now, I could simply not use my container 1. I can actually display my button on my top level window. But again, what we're doing here is we're showing how we can link a control button to a container, a parent container. Okay, so that's what we're doing. We're kind of referencing the control to the container. Okay, and again, it says widgets have many attributes which are stored in their local namespace dictionary, and I think we can explore some of those different attributes for buttons and for so on. Example, if you want to define the text of the button, right? Because the button itself is an instantiated object of the button class, right? The text attribute of the button, we just put in text, and it's equal to hello world. And this is again using the whole dictionary style that we talked about last week for Python. Python uses the class button, uses a dictionary style properties to define its attributes. Okay, so text button 1 text is equal to hello world. Our button will change this text to hello world. Button 1 background is equal to green, and green is a standard color that the button class has. it'll change it to a standard green color. So all up green and red and blue are going to be 0. Then we pack the button. We display the button on the screen by using that pack method. So these 3 lines right here are the way we first define the button, the widget that we're defining, and then we're outputting it to the screen. Now, right now it doesn't do anything. We're just defining the button itself. Okay, so that's the first thing we have to know. So let's go to this button.py to kind of look at that. Okay, so killing this one, going to button.py. Okay, let's take a look at this. So again, same kind of elements. Here's our top level window. My container is defining the frame, which is linked to our top level window, right? Because root, we're passing root into our frame. So it says, hey, the root window, or this top level window, this TK class instantiated object is our root container, right? This is our container, the second container that's layered on top of our top level window, right? And then we're going to pack, we're going to display our container. And then we're going to create our button, we're going to instantiate our button class. And if we don't put any of these attributes, it's going to come up blank. If we don't actually define the text or the background, it's going to be some standard values that the button class has built in. Okay? But in this particular case, we're saying a text is hello world, and our button 1 background value is equal to green. Okay? We can change that later on. And then we're going to pack the button. Right? We're going to actually display the button. Some of you may be right now saying, hey, wait a minute, but where's that button going to be displayed to? Is there going to be, there's no geometry here, right? And you're right, because frame and pack methodology for Kinter, it doesn't specify a X and Y geometry. It uses left, right, up and down, north, south, and so on. And you're going to see that that is not as, in my particular opinion, as useful as the place geometry manager. Okay, let's take a look at this button here, see what it looks like. So here it is. And again, I'm going to expand the window so I can actually move it. Again, I haven't changed the caption of the window. It's still TK, but if I click on the button, it does what a normal button should do. It actually looks like it's being clicked, right? So I've defined a button here. Now, if I change this, and if I change this from green, I'm just going to take a gander, and I'm going to take a guess and say black, right? If it's true, if there is such a value, then sure enough, my button is black, but my foreground colors are also black, and that's why you can't see the color. And there's a little bit of a commercial, so I'm going to pause for a second. So I'm pausing for the ad. Some of you may see it, some of you may not. And that's our first ad. And here's our second ad. I see some of you come back. One of you come back. Any questions so far, guys? If you want to send up a question up online, I can try and answer them as we go on. And again, I should have a little bit of time at the end for questions related to assignment number 2. I can stay a little longer as well. I don't have to finish exactly 2 o'clock for those people who want to ask some questions. We can also do some one-on-one question answer with Uvu, which I talked about before. All right. And we're back. So again, what I did before was I changed this value to black, but that's the background value of the button. If I wanted to, I'm guessing that if I went button 1, and if I type in foreground, and I'm just guessing here that this would work this way, is equal to white, right? Then we actually can see our button. Now, if you notice, it's giving me an error. It's saying, hey, oh, it was an error. Didn't know what this foreground function meant. So let's see if I'm right. So I'm going to run the program, and if it doesn't crash, and here you go. So I've actually changed the foreground. I've added another foreground attribute. I've created a foreground attribute and made it white, and that's what's generating our button to be black background, white foreground. And if you notice, and if I click on it, it does what a button should do. Okay, I'll close this off, and if I was to delete this, okay, and I change this back to green, that's what we had it before. And if I just for the sake of, I'll keep hello world as the text, but I will comment out this this command. So I'm not actually putting this a background attribute at all. Let's see what the standard attribute is. If I actually run it, and here we go. This is our standard button. This is what a standard button looks like with no configuration, right? With that, except for maybe the actual text. So if I click on it, again, click it a click, It works like it feels like a standard button. Okay, and we'll just go back. I'll put it back the way it was. All right, and we'll go back to our presentation. Okay, so we've done a couple things here. We created a button. There is no real geometry that we're using right now for the button at all. All right, just creating the button and throwing it on the screen, and it's throwing it, if you notice, in the middle of the screen. Right? Okay, I really should handle classes and objects now, because as we move forward, and you're going to notice more and more stuff about classes and objects, we're going to talk about classes and objects a little bit today. We're going to revisit them again as we move closer, more deeper into the Pygame framework, because we have to understand how classes work, especially with the Kinter. Right? So I know we're kind of lesson number 4 and we're talking about classes, but really that's where we got to be at this point in time. All right? So I'm not going to go into detail of what an object is. If you don't know what an object is, then by now this is like your xth or nth class that you've done. I'm sure you've been exposed to class and object, but really the things you have to think about is there's different types of values that are stored inside a class, right? And really, class is a group of objects. I think it's the main thing here in one convenient space that you can access, right? So here's how we define a class. So let's say, for example, here's a person, and this is from the basics of defining a class. And we've seen classes in other languages again. So we're defining 3 methods here, right? The class person itself, just like we would if we're defining a function. Instead of the def being in front of a function, now we're putting the keyword class, right? So class person, right? If you notice, classes from a best practices perspective are all in caps, right? The first character is caps, right? And now we're defining some methods. Each of these functions inside of a class are all methods now, right? So inside of a class, they're methods. Outside of the class, just like in other languages, they're kind of viewed as just functions, okay? But in this case, if you notice, we also have this self keyword here, right? Self. And that's a difference between how you can see if it's a class method or a function. If it doesn't have a self keyword, chances are it means it's just a regular function, right? It's outside of the class. Okay, so here's a method. So the first method is setName. So here's some getters and setters, right? As you normally would see in other kinds of languages, right? And you have your basically your input here is name as a variable, right? And what you're saying is you're creating a property for the class itself, a class variable, a class property. You're saying self name, so the name of the class itself is equal to name, whatever the name variable is that comes into this setter, right? And if I want to use a getter, I'm basically what I'm using here is I'm saying get name, right? And I'm saying I'm going to return the name of the of this field or property or variable, class variable, that I'm going to return out when I access the class itself. And here I don't have an actual a getter or setter. I'm not actually outputting anything. Here I'm actually doing something, right, with my methods. Remember, methods do something, right? So I define a method called greet. Well, I'm going to greet this person, right? And I'm going to say, hello world, I'm whatever my name is. Here's my name. I'm going to output. Now, obviously, if my name hasn't been defined here, as an example, it'll give me an error because I have to define my name. I have to create the default for my name, maybe blank in my class itself. So this is kind of an incomplete class here. But at least you understand that these are 3 methods that we're defining within our class. Okay, so the person, the name of the class, set name, get name, and greet are names of the methods that belong to that class. And attributes, again, the attribute that we're talking about here is self, or is name. That's the name attribute. And self.name is the way you make it a class attribute, or a field, or a variable. Different names for the same thing. And here's some, for example, a class car. You might have a name for the car, color for the car, number of tires, miles per gallon. All these things are attributes or properties for the class itself. Okay, so we're not going to go into what classes are too much, like I said. And then methods, of course, do things. So there's start, you can stop method, number of tires, and so on. And you might have a start and stop particular objects within your game loop. You might have a start and stop for types of enemies, or a start and stop for a type of door, or whatever. So there might be different methods that you use in your class to do things. Okay. So really, the self parameter is like this in other languages. You might see it as this, but self is also used in other language syntax as well, right? So here's an example. I'm defining a class, right, which you can totally do. And in this particular case, I'm saying my method is called method, right? And my method actually prints I have a self. That's what it does, right? And here's a function which is totally not part of this class. This is outside of the class. And if you notice, that's what I said before. A method has a self, and a function does not, right? And here's where I'm saying instance is equal to class. I'm actually instantiating the class here. And when I say instance.method, I'm actually calling the method of that class and printing it out. And we've been doing that all along. Actually, we've seen that on the Pygame side. We've seen that on the Kinter side. I'm just zeroing in here on this stuff so you understand a little bit about classes before we move into more difficult stuff. All right. So the init method, which is really the constructor, that's really the constructor of our class. Whenever we see this init method, when you create your own classes, you actually create the constructor for that class. So this is something that the signature, if you will, of that class. You can also create more than one init methods, or overload the constructor, if you will, as you go. So you can have more than one option for the constructor, as we do with other kinds of programming languages. Okay. So really what we're talking about here in this slide is why we use a class structure, because it's much easier. And if you remember, if you were taking your assignment number 1 and you used classes instead of functions, right? You could define, and I kind of hinted at this in class, right? If you were to use object-oriented programming for your solution for assignment number 1, I would definitely give you a bonus mark, because I think that's kind of the way we have to go towards. But I also wanted to kind of give you a quick and dirty, here's an intro to Python, right? So I didn't really kind of make you do it. But going forward, we're going to talk about how you should use classes when you develop your code, as you should with any other class that you do here at Georgia. Okay. So here's a restructured version of the program. Okay, we do 3 different things. Here's my app. My app, of course, is an instantiated object of the class. Okay, and let's take a look at the my app class. Okay, so we're going to run myapp.py. Let's look at this program as I switch back to Aptana. And here's my app, right? So we're doing the same thing here, except now we put it all inside this class structure. Okay, so we've defined a new class called myapp, right? And now in here we have a constructor, and the constructor is going to basically create my container 1, which is going to link to my parent, and my parent is going to be passed into the class right here, right into the constructor. Remember, you can pass variables into the constructor itself. So here I've got my app. I'm instantiating my app, and when I do, I'm passing into the constructor this variable called root, which I've defined here as the top level variable. Top level. Okay, and you're going to do the same thing with Pygame later on. Okay, so now I'm saying here's a couple of objects here. My container is equal to my frame, and it's kind of linking to my parent as a top level container. I'm packing it exactly the same stuff as we did before. When I instantiate this class, I instantly create my window, of course, and I create this other container, this frame, this surface object, or this container, that's going to include a button with a text value of hello world and a background of green. And then I'm going to pack it on. I'm going to pack this button onto the frame that I'm looking at. Okay. So as soon as I instantiate my app, which is the app that I'm running, I'm going to do all this stuff inside the constructor right here. All this stuff is going to be run as soon as I call my app as an instance of the class my app, capital M. Okay. I still got to do this though. I still got to run main loop, which is basically the method that's going to kick off the window. All right. So after I've defined my class and defined my object my app, it won't do anything until I've defined this root.mainLoop method. Once I've called this method, everything kicks off, I'm in the main loop and I can do stuff in it. Okay, so that's really a modified version of our Kinter. Okay, and let's take a look at that. So if I run it, it does exactly the same thing. It performs the exact same way. There is no difference between one version, the version that didn't have classes and objects, and this version here. It looks like it performs the exact same way. Okay, so why bother using this? Because this is more structured, and we're going to see as we move forward this structure using classes and objects is much preferred over the non-object oriented approach. Okay, let's go back. And my shockwave flash has crashed. All right. I'm just going to pause 1 second while I go back to my, I don't know why, but on my other machine here, it's kind of crashed my browser's kind of crashed. Anyways, all right, continuing. Here's where we do the edit. All right, so we talked about how to use classes and objects, right? A little bit. Let's take a look at this other example, which is called MultiButton.pie, right? MultiButton.pie. Okay, so I'm going to switch out of this and go back to MultiButtons.pie. All right, here it is. So again, this is a much more complex class. Well, it looks more complex actually, but it's the same thing really. What you're looking at is a larger constructor. This is all within the constructor method, right? All this stuff here happens within the constructor method, right? All right. So inside the constructor method itself, you're going to have the same first button that we created here. I'm going to pack that on, and now we're going to create button number 2, which we're going to define, and we're going to pack that on, right? We're going to define the text and the background as tan, right? We're going to do that as well. And here we're going to pack that. We're going to do a frame. We're going to pack. We're going to define. We'll configure the button and then pack it on. We use pack geometry to do that, right? And the same goes with this button 3 and button 4. We're going to do this all the time. So there's going to be a bunch of buttons. Still, they don't do anything, these buttons. And if I display this program, right, you're going to see each of these buttons is one on top of the other. It's like here's the next one, here's the next one, here's the next one. They're all kind of one after the other, and they all pack in the middle. They all display in the middle of the window, which is kind of useless, right? This is not good. This doesn't give us any control. All right, so we're going to talk a little bit more about controlling this in a sec. Okay. So let's take a look. So here we have a couple of attributes we can use with the pack geometry manager. We can say side is equal to left, right? Again, we can use left, right, top, or bottom. These are kind of user-friendly constants defined into Kinter, right? But if you notice, the pack geometry manager doesn't allow us to do x and y coordinates. But let's go on with this first. So let's look at side-by-side.py, another option, another program that we kind of do the same thing. And again, all we're doing here in multi-button before we go on is we're still defining my app again as we're instantiating my app as the class, and we're running this code. After we instantiate it, well, the constructor does all this stuff, right? As soon as any kind of class is called, the constructor is initiated, if you will. Okay, so let's go to the next one. And again, we're going to call it side by side, right? So here's another class that looks very similar to the first class, right? Right. So the class that we have here is a bunch of buttons again, and except this time you've added some attributes. Right, here's left, 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 left. These are all side by side, right, to the pack geometry manager, right? So if I look at the options, if you look at it, you can actually define as many attributes as you want. Now, if I was going to type in this command, if I went to self, and here I'm in Tana, button 1 dot, and if I look at different options, button 1 dot, I don't have attributes as an option, right? But it says inside, if I hover over it, that I do. We're going to go over that in a second. So I'm just look at here for a second. If you look at pack, if I hover over this, look what it says. Self.button1.pack, right? And the button to attributes. There isn't actually an attribute method. We're going to configure that as well. Okay, so you can pack left, right, and so on. And let's take a look at how this works. Again, this is not very good, right? Because again, all it does is allow us to pack buttons all in a row. Not cool, right? Again, not a lot of control here. Okay, let's go back. But it's a little better because it does allow us to do some kind of formatting, but not a lot. Okay. And binding, we're going to talk about binding in a second. Before we do more formatting, binding is actually what creates the event handler. All right, and here's what this is the general form of the event handler. So you have your widget, whatever your widget is, right? As an example, in this particular case, our widget is a button, right? The event type name. So in this, if we're listening for a mouse up or mouse down, there's a bunch of different event type names we're going to go into. And then the event handler name we're going to create. We can create its own method or function, if you will, that it can go to. You know, again, from a Java perspective, they're called listeners. In Python, they're called handlers. Okay, same kind of thing. Okay, but really, this is the general form: the event type name and the event handler name. And when you use bind, that's one type of event handler that we can create for buttons or other objects. Okay, so let's take a look. So again, button 1, if you notice, this is just the format. Button 1 will be your left mouse button, right? That we're going to bind with for this particular button that we're going to create. So we're going to listen to button 1, right? And then what we're going to do is we're going to create our own button1.click method that we're going to do stuff in. Okay, so let's take a look at that. Okay, so let's look at event_button.py for more details. Okay, and this is the last slide of this before we go into some assignment stuff. We can talk about assignment number 2 in more detail. Okay, so event_button.py. So I'm going to close this off. Go to event_button.py. Okay, and if you notice, we have the same kind of thing. We have our frame, we have our top level window, we have our button, and we have the configure. We have our configure command. We're saying our button mark, and we're doing it in one blow here. Before we did it in 2 lines. Here we're doing it only 1 line. Text is equal to OK, background is equal to green, and you can do foreground and so on, all in 1 line. Okay. Here we're packing the button, and after we display the button right here, then we're binding it. All right, and we're using a standard set of listeners. And in this particular case, we're listening for button 1. These attributes, by the way, I have them in a separate file for you to use. I'm going to look at that in a second. And then what you're going to say is self. You're going to call this function self.button1click. Well, this function or method, right, is right in here. So here's button1click, right? And if you notice, it's still part of the MyApp class. It's a method of the MyApp class, and it has to have self, because remember, methods have self in them. And it also has to have this other object called event, right? Here's the event object. So if self.button1 background is green, which in this particular case, it starts off as green when we use this before we hit button1click, right? It is green. Then I want to change my button background to yellow. So this event handler is going to do. Else, my background is going to go back to green. So if it's yellow or another color, it's going to go back to green. So that's what this button1click event does. So that's the method that's tied into this handler. So this is the handler line. Again, we're doing a couple things here. This bind method actually creates the handler. Okay, we're listening for that. This is the type of event we're listening for, a button1click event, right? And this is what we're going to do when we hear that event. Right? We're going to, activate this. We're going to call this method. Okay? You can actually call this method on its own, right? And remember, because it's still part of the class, I can actually go whatever the class name is, myapp.buttonClick, button1click, and then it will accept, as long as I tell it the type of event, it'll do different things. Okay? Same thing for button 2. Here's button 2 that we've defined as a button, right? Same as we defined up here. In this case, we're going to create a cancel button, right? So this is the OK button. This is the cancel button. My cancel button is going to be red. My background state, and my state, here's another attribute, will be disabled, right? So I can kind of create different enabled or disabled, right? And here we're going to pack it. It's going to be at the right side of this other button here, right? And we're still listening for the button 1 or left mouse button event. That's what we're doing here. Except this time we're going to a different method. We're going to hit this other button to click method that we've defined down here. It's part of our class, right? And what we're going to say is, hey, as soon as I click on my cancel button, I'm going to destroy my parent. Oof. That means I'm actually going to cancel the entire thing itself. But you know what? It's going to be disabled at first. We can't really enable it because I haven't really told it to be enabled. So in this particular case, in this code here, it'll never be enabled. We'll never be able to click on it because we haven't said once we click on this enable my button. We never said that, right? Because right now the state is disabled. Okay, let's take a look and see how that works. Okay, so here's our 2 buttons now. And if you notice, I can't, oops, I shouldn't be able to click on it. Let me try that again. Right? Because it should be disabled. But guess what? I can click on the OK button and it'll change color. But as soon as I click on the cancel button, it doesn't matter if it says disabled or not. And this is one of the foibles of this configure and this type of binding. It'll never work. It won't allow you to disable the button. Not from here. Okay? So we think from a state perspective, this should stop the button from working, but it doesn't. Now I've got another version of this code called eventButton1.py, right? So here it is again. Here's another method. I've got let's just run this thing so you see it. Right? So I've got 1 plus 2, right? And if I click on, here's 1, here's 2. There's different buttons here. If I click on equals, right? 1 plus 2 is equal to 3. If you look at the bottom here on my console, right? 1 plus 2 plus 2. And if I click on equals, right, is equal to 3, right? It actually does something on the console. So let's see how that works. You have 3 buttons. 2 of them are useless. Only the equal sign really matters, right? Because it's going to keep on spitting out equals to 3, right? That's all it's going to do. But this is another way of creating buttons here, right? And if you notice, we've just defined the backgrounds and for these buttons a little differently than before. This time, these print statements, if you notice, all these print statements are going to the console. We're actually creating an output to the console with this event button 1. Okay. So we've covered a couple of things here, and we're kind of coming on to the. We've been kind of going for about 2 hours and 37 minutes now, minus a break. So we've kind of covered the Kinter framework a little bit. We've covered Pygame, and we've covered a simple button, but we really haven't covered the geometry manager that I really would prefer that you use. All right, so let's talk about that a little bit. And I talked about this before too. I said, hey, you know what? I'm just cancel out of this. What I really want to do is, and I'm just going to look at the button widget a little closer with this presentation, right? The problem with the pack geometry manager is it just packs it in any old place. So here's some button options. You can actually define your active background, your active foreground. There's anchor and so on. I've taken all this from the Kinter documentation that I found online. This is all stuff I haven't created. This is all stuff that you can find online when it comes to Kinter. Okay, so this is all your button attributes here. Your border width, your background, your bitmap. These are all things you can do to define your buttons. Okay, and here's some more. So I've kind of created almost like a reference card for all this stuff here, right? You can also talk about dimensions for your button, right? So when it comes to dimensions, C is centimeters, I is inches, M is millimeters, and P is printers points, right? So sometimes you'll be using these dimensions for units when you talk about stuff for buttons themselves. Okay. So here's an example of some event sequences, and that's what we were talking about before. Your button 1 is really an event sequence that you're listening for. There's also a key press in this particular H, is you're listening for the H key. Then you have a Control Shift key press H, right, which you're actually listening for a Control plus Shift and an H, right? So this is the different kinds of, this is the format or the general form of advanced sequences, okay? So let's take a look at some others. So here's some modifiers: Alt, any, Control, double, so on. These are all different kinds of modifiers you can add in to your key presses, as an example. Okay, so here we go. So Alt L would be the left-hand Alt key. Alt R would be the right-hand Alt key, and so on. So these are different kinds of sequences that you can put on, that you can actually listen for when it comes to your key presses for your buttons. Okay, so either key presses or whether it's actually mouse presses, these are all them. Okay, and they're inside this file that I've kind of put up online under Lesson 4, the button widget. But there's still something else we need to cover, which is, hey, how about this pack geometry that Tom says really sucks? How do we deal with that? And in here, right, it talks about different kinds of geometry managers. If you actually look through here, this documentation is pretty good. So if I actually click on Python Kinter resources, it's going to go through and redirect me to different places where I can learn Kinter, right? And in that one document I just downloaded, here's that the latest document of Kinter 8.5 reference, because it's the latest one, right? We talk about different geometry managers in here as well, right? So if we want to find this is all for the pack geometry manager, but what we need is a place geometry manager. If you notice, it's not covered in here because the majority of the geometry managers that are covered are grid and pack, right? Because those are the most common ones. But if you notice, look at this. So here they talk about how to manage the grid when it comes to your geometry, and I recommend to you that you look at pack or place geometry, right? So if I was to look up the place, here it is. I go to www, go back to Google, use my Google food, right? And I go, so place geometry manager, Kinter, right? And then if I want to look at it, and again, I'm just looking at the first place I'm looking at. Here's an example of this. So again, W would be your window. Place would be the different type of geometry manager. And then you have something called relative X and a relative Y coordinate system and different anchor if you want to or not. So this is what it looks like. If I'm creating a button, so B is a button that I'm creating. Here's my pane. Pane is my frame, right? My width is 12. My height is 12. So I can define the width and height of my buttons, right? I can also create an image for my the actual button itself. This was called a launch icon. That's my image itself that I've defined. And my command, different kind of binding, command binding instead of the method binding, right, is self.launch, right? And here's where I would actually do how I would make my buttons work. But if you notice, the place geometry manager tells me where my button lies, right? Relative X and relative Y, X and Y coordinates, and all that kind of stuff that I want to use. Okay? So this is the stuff that really works well for me, except it looks really complex. So how do I, if I was going to create this slot machine program, how do I do it? What's the main method that I want to use to quickly create my slot machine program? And I've kind of said it last time when you guys were there. There is a quick drag and drop a tool for Kinter called Page. And again, I would go and find that in Google. And if I go Page for Kinter as one of my searches in Google, I can actually, it says there, Page, a Python GUI generator. So if I go here, it'll tell me a way to download Page. Now, I'm all for typing things by hand, but this actually creates all the details that you need for an for your assignment 2 framework. Okay, so let me explain that a little bit. Okay, so right now, in order for you to use Page, you need to have Python 2.7 or Python 3.2 working on your system. Okay, And what you want to do with Page, these are all the widgets that are supported, all right, with Page. These are the things that are automatically generated, all right. And there's also something else called TTK. This is an extension of the Kinter library that I'm going to be using. Okay, here. Okay. So you install Page, tells you how to install Page and everything else, and how to generate stuff. So I would encourage you to look at this, all right, to generate your basic functions. But I've got my Page already set up. So once I've kind of loaded Page up, let me just go to my desktop here. So here's my desktop, and now I want to create my page, if I will. So here's my page. This is my page drag and drop code. Very, very rudimentary, like I showed you guys in class. So once I double click on it, and eventually it's going to run, it's going to show you the framework. Here it is. So there's a few things that come up. Here's the attribute editor that comes up. Here it is. And this is my my widget toolbar that I can choose from. So I want to create a top level window. That's the first thing I want to create. Now for Page, once you have this set up properly and running, all you need to do is point at top level. You don't have to double click on the site. Point at it once. So here it is. Right. So here's my new top level window. And if you notice, my top level window, I can define its attributes right here. So right now my alias is top level, right? I can define my attributes for the top level window right here. The maximum size, the minimum size, the window width and height, and so on. So for example, if I want my window to be 320 by 480, right? If you notice, my window changes automatically by 320 by 320 by 480. Here it is, right? So here's my new top level window, and it looks like the same size as that mobile phone device, right? So this little nifty attribute editor allows me to change what my window is going to look like before I open it up. Okay, that's number one. Now I may want to or may not want to add in a frame. I don't have to. I can use a frame. I cannot use a frame. It's up to me, right? And a frame is just another container within my window. Okay, but what if I want my window, this window itself, to have a background image? And if I look through here, can I do it? And if you look through, these are different options that allow you to get a hint of what you can do with your top level window. I can add a menu if I want. You know, I can actually set the focus, take focus. My own little window will initially start with focus and so on, right? I can create my state, whether it's iconified or not, or withdrawn. I can make it visible or not, the whole thing. But I can't really establish a background to this window. If you look at, see, here's my highlight background, and here's my container. Is it a container, yes or no? Right? Right now, it's not a container. I can make it a container, right? So it says, look, can't modify my container. Anything I want to try and do is going to give me an app. Here's my background. My background right now, right? As an example, I can create different colors for my background. So right now, I can make my background red, right? I can change my background to whatever I want, right? Or I can kind of look up a color palette of colors that I can choose from, that I can make my background color. So here's an example of that. My border width, I can create my border width of, I don't know, 2 as an example, right? And I can change my border for my window or not. I can unclick that. I can unclick this too, right? Anything I don't want, I can kind of destroy. I can go back, make it white as an example, and it'll do whatever I kind of tell it to do. This tool is very simplistic, right? So here it is, right? Border width of 2, I can take that away. Here's my color map. I can change the kind of cursor that I have when it's in my window. I can make it so my cursor is a boat, right? So here's a boat, see? That's kind of silly, but I could. I mean, there's different options for the type of cursors you have. A circle or a box or a spiral. Here's a circle, look. So I can change the cursor type for my window. I have a lot of control over this window, right? Now I can also do things like add in a button. I can add some buttons to the window. Here's a button, right? Now that I've clicked on this, the button, right? I'm actually, my properties are now aligned to the button because I've clicked on it. If I click on the window again, my properties are aligned to the window. So here's my button, right? And now if you notice, my button doesn't really have a name. Here's my text for my button. I can change this to OK, right? So there's my text of my button, right? Without knowing the properties. And I can create another button. Here, let's just drag in another button here, right? And then this button I'm going to call cancel, right? So here's OK and cancel. And again, I'm going to move this button around. I can position this button exactly where I want it, as opposed to kind of guessing where it's going to be. That's why I like that. And this is all done with the place geometry manager, right? And if you notice, here's my X and Y position, 30 and 430, right? 30 and 430. I have a northwest anchor, and we'll talk about anchor another time, or I can make it a center anchor, right? But right now, northwest is, and we'll talk about where that is, but really it's north, right, and west, right? 30 and 430, and then I can choose relative X and relative Y if I need to. All right, so here, and if you notice, I'm created these two buttons. Now, if I want to define my Python, I want to generate my Python, and I click on this page window here, and I can say generate Python. It's going to ask me to save my code somewhere, but I don't have to. And in fact, if I just use this to generate my Python, I click cancel, it'll throw up an example of my code, right? So here it is. Here's my Python code, right? Now there's a couple things I don't need here, right? I do need this class. This class here, new top level 1. I do need this part, right? Because this is where I define my class. And I'm going to call this class new top level 1, whatever I want. Later on, I could redefine this class to whatever it needs. Okay, I don't need this other stuff. I can just kill all most of this. This stuff, root TK, I need. Root title is my top level window. Root geometry, this is how big my window is, 320 by 480, and it starts at 832 by 214. That's what this means, right? And then here, what I'm doing is I'm saying I'm creating a new window. Once I've created my root, I'm creating my new top level window by using my new top level 1 class, right? Which is kind of silly, and I'm creating it with I'm calling it W, right? So this is kind of like a template to create what I need, which is kind of cool, right? All right, so let's continue with this example for a second. I'm going to cancel out of this, right? And I'm going to actually close this off. I'm going to quit. Okay, so I'm going to quit. I'm not going to save anything, and I'm going to start it again. Okay, so here we are. Same thing as before. A new top level window I'm going to create. Here's my top level window, right? So and again, new top level 1 is what it says here. I may want to change this this alias to whatever I want. So I'm not going to call it top level. Maybe I'm going to call it main window. That's what I really want to call it, right? So here's my top level window, right? That's the first thing I'm going to do. If I'm going to try and change my alias to whatever I want, let's move this away. Let's see if it works. Right? So my window. Right? Now if it works, right? This is my window, right? My class, I can't modify it, not from here, but I can do it after I generate my window. Okay, here's my title, from the title of my var. So here's my page test, right? That'll change the var itself to my page test, right? So change the geometry. I can actually, this is my X and Y position, my starting X and Y position of where this is. If I move it, it'll just change my X and Y position. This is what this is right here, right? And here's my width and height. And again, if I want to make it 640 by 480, I can control this a lot better than I did before, right? Okay, and there's some minimum, maximum size. I can also say, can I resize the width? Yes or no. I'm going to put no, and I can't resize the height. So now my window is just like my Pygame window. I can't resize it. It's exactly as it was before, right? And this is the kind of stuff, the controls that I use when I created my game, right? So all I'm doing here is I use page as my framework to create my game. So let's take a look at my initial version of my game. And I'm giving you a hint here what to do. I think this is a great little tool to create your structure from scratch. Okay, so let's take a look here. I'm going to X out of this and not save anything. And let's go back to Kinter. To my code, and let's look at assignment 2 solution set, which is what I did. So remember, the first one that I created, this is the stuff I shared with you. All it is a text-based game. So that's what I did here. Okay, I'm just going to exit out here. The second part, here's my second part. This part, I used my Python slot machine class I renamed the slot machine to Python slot machine, right, from top level window. That is my class that I'm defining, right? And if you notice, way down here, right, root is equal to tk, root titles Python slot machine. Here's my root geometry, 600 by 400. You can change this to whatever you like. This is what matched my image that I loaded in, right? And here I'm defining my my Python slot machine as is my my class, and I'm instantiating my class with W. Now I'm using the same. I use this to point out that I use page as my my structure, if I will. First, I have to understand Kinter a little bit, but once I do, I can use page to use drag and drop controls to help me describe my GUI, all right, which is really, really cool. All right, so here we go. There's a couple other imports I made here too, from to Kinter import star, or TTK import star, from to Kinter import star. This is all stuff that comes right out of page itself. Okay, so I did a couple things here, and I'm showing you this because, and I'm going through this on video. So if you were to actually look at the video, you can actually go through this and figure out how I set up my class. Okay, so let's take a look as I move further down. What I'm doing here when I define my second option here is I'm saying, hey, here's my class. I've set up some properties of my class itself, my win number, my bet, my turn, and so on. And here I'm actually defining my buttons, but I'm using the new geometry manager, right? Here's my height and width. Here's my relative x and relative y, but you don't have to use relative x and relative y. You can actually use x and y coordinates, like actual x and y coordinates for your window. And then I want a hand. My cursor is going to change to a hand. I'm configuring my text to close, and I'm creating a button called button 1, and I'm creating this self.button1 click event. Okay, that's what I'm doing here. So this is an example of the first button. So when I actually run this code, right, here's what it looks like. This is the second version of my code. This is like me translating the other type of code that I used before, which was just a console, into something that works with the Kinter library and page as my structure. So here's, for example, my jackpot 500, my money 1,000, my current bet is $100 as an example. Once I click enter, my spin button becomes available. I can spin it, and then I can continue to spin and lose money as I go. And then I go, and then if I win, it's actually going to give me some output here. I can close, and it will close off my program, right? So again, I use my spin button. Here's my reels, right? As an example, I've defined different different kinds of buttons. So here's my 3 reels, 1, 2, 3. So this is where the information for my reels are going to go, right? As an example, right? Here's my my jackpot, different labels that I've created. And again, these are different objects that you can define with Kinter. If you read the Kinter documentation, I can configure the font and the text for the label, just like I do with the button. We haven't talked about labels yet, but we will. And I've created other things here. A jackpot entry, which is an entry type of a control where you can actually enter information. This is a text area that I can actually enter information, right? And so on. So I've configured all this stuff inside my class, which is actually, as soon as I run or instantiate my class, this is all inside my constructor right here. This is my constructor, right? And then I have a bunch of different kinds of methods, right, that allow me to do something when I click on my buttons, right? And if you notice, I still have reels, just like I gave to you guys in slot machine 1, and pull the handle. These two functions that are outside of the class are still being accessed down here, right? So as soon as I run my my class, right, I still use reels and pull the handle, and they're outside of my class. I can do that, right? Not a great practice. Theoretically, all this stuff, these should be actual methods that are inside of my class itself. And actually, in further iterations in my code, I did that. Okay, but that's the kind of stuff. And if you notice, in version 3, and then I'll stop after this. In version 3 of the code, again, I'm doing the same kind of thing, right? Except this time, if I go down, I'm actually using a Pygame mixer. I'm actually including Pygame right? Here's the way we do Pygame audio in my code, right? And I'm actually using my mixer controls to define a couple of sounds that I have in my library. And if you notice here on my resources, I have images and sounds. That's where I've broken down my my resources for my game, right? And I'm using different objects. So I'm creating a canvas. This is where I actually have my images. And this is what I suggest you do, right, for your particular code as well. I don't use a frame. I'm using a canvas for my button, for my background for my slot machine. And then I'm saying, well, you know, I'm going to load in something called a photo image, right, of my slot machine GIF file that I've got, right? And then what I'm going to do is I'm going to use this create image method to actually throw it up on the background. So this is the actual background for my slot machine code right here. And then after I do that, I got a bunch of labels that I layer on top of my image, right? And if you notice, right, here's my canvas. I call it background panel, right? And my labels are actually using the background panel as the parent for my that they kind of lay on top of or layer on top of my labels. Here's my labels, and the same thing goes for all my buttons. So my buttons are actually using the background panel as well, right? So there's a bunch of different things that go on here that you can use this page program to define. Anyways, that's it for me for this week, and we're going to do more on this next week when we get together during our regular scheduled class. Again, I'm going to stick around to see if you guys have any questions. But for now, I'm going to sign out and stop this streaming right now, and then we'll start it up again with just questions and answers for anyone else that's sticking